This time on Battle Factory. The military menu that feeds the fight. The weapon that puts flexible firepower in the soldier's hands. And get the real feel of flying without ever leaving the ground. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. This packet contains enough food energy to keep a soldier fueled for the fight. The MRE, or Meal Ready to Eat, is a nutritious food ration distributed to servicemen and women in the field that can be heated on site in mere minutes. 100 years ago, dinner in the trenches of World War I wasn't as appetizing. Due to short supplies of staples and poor preservation, British troops subsisted on thin soups flavored with mystery meat, canned corned beef, and bread substitute made from dried turnips. Tins of sugary tea masked the flavor of water transported in gas tanks. Today, combat meals have been replaced by the MRE. The MRE breaks down into the flameless ration heater, the pouch of water, and the meal bag. The meals ready to eat must be prepared in a sterile environment to prevent bacterial contamination. One recipe is made at a time in an industrial kettle. First, the pre-cooked ingredients are brought to the kettle. Today on the menu, chicken with barbecue sauce, black beans, and potatoes. The preheated barbecue sauce, fortified with extra vitamins and minerals, is pumped into the kettle. Then the ingredients are poured into the sauce and mixed. Frozen chicken, dehydrated potatoes, and black beans. The MRE is health food and haute cuisine compared to the C rations of World War II. The C stands for combat, but it might as well have stood for canned. Canned meat, canned bread, and canned dessert. Affectionately known as C rats, they were only intended to feed a GI for a few days before being supplemented with real food. But toward the end of the war, C rations were all they got. By the late 1950s, the Army accumulated such a large stockpile, they were able to feed soldiers these temporary meals right through the Vietnam War. The meal bags are made from a combination of strong, flexible plastic and metal foil, making them highly durable and puncture resistant. The barbecue chicken meal is now pumped through a reservoir at the filling machine. The meal bags travel along a conveyor system where they're stamped with the ingredients, the plant number, and the date of production. Then, each bag is blown open with air jets, and the 228-gram meal is pumped into each bag. Each kettle can produce 1,400 meal bags every 20 minutes. Before being sealed, the bag is blasted with air to make sure no food is blocking the mouth of the bag. Then, the bag is heat sealed. An 8-hour shift can produce up to 100,000 meal bags. By the time the World War II C rations had arrived in Vietnam in the late 1960s, they were over 20 years old. And because the paper label often slipped off, every meal was a surprise. Today, MRE menus include Asian and Caribbean dishes, and there's even a vegetarian option. When the packages arrive at quality control, they are X-rayed for impurities, and every batch is sterilized and monitored. Samples are put into testing bags and sent through a sterilization chamber along with the rest of the batch. The monitors track the exact temperature, ensuring that the contents of the meal will be safe when reheated in the field. If a soldier gets sick to his stomach on the battlefield, he's at risk to himself and a liability to his squad. So food in the combat zone needs to be plentiful and safe. Every MRE contains 2 entrees and 2 sides, like high-energy bars and drink crystals, for a total of 1,300 calories. The packages also contain a pouch of water and 2 plastic bags called the Flameless ration heaters. The bottom of the bag is a package containing magnesium mixed with metallic iron particles and table salt. Adding water causes a chemical reaction that heats it until it boils. The meal bag is inserted and left to heat, and the meal is ready to eat in 10 minutes. The final step is to seal the bags with cutlery and napkins. Then they can be packed and ready to ship to the field. War is no picnic, but if an army really does travel on its stomach, the MRE is the fuel that gets them to the front lines. Coming up on Battle Factory, a weapon with 150-meter range that doubles the fighting power. And climb aboard this craft, and you can take off without a runway or an airplane. Using the latest technology, these harmless bits of plastic will be melted and molded to create a snap-on weapon that drastically increases the firepower in a soldier's hands. The M203 grenade launcher is a single-shot launcher designed to attach under a rifle barrel. In World War I, the original grenade launchers were the infantrymen themselves, who both lit and lobbed the mini-bombs from the trenches. They could throw the grenade 15 meters fairly accurately, but would have to duck for cover to avoid the shrapnel from the explosion. The Leach Trench Catapult was the first attempt at a solution, sending the grenades as far as 200 meters, but the aim was iffy. Today's version has both range and precision. The M203 grenade launcher breaks down into the barrel, the hand grip, and the receiver. The receiver of the grenade launcher is what contains the firing mechanisms, houses the barrel, and connects the launcher to the rifle. It starts off as a block of aluminum that's precision cut on a CNC, or computer-controlled machine. Once cut, the probe calculates the exact measurements to make sure that every dimension is to spec. It was originally designed to fit on the M16 rifle, but is currently compatible with many rifle models. Once the receiver is passed inspection, it's engraved with a serial number and registration code for security and quality control. Next, the receiver is anodized. The aluminum is dropped in an acid bath and charged with electricity, which alters the property of the metal surface, making it harder and rust-resistant. Once the receiver is treated, its moving parts can be added. First, the barrel latch locks the barrel and receiver together. Then the barrel stop goes in to prevent the barrel from sliding off the receiver during loading and cocking. Next comes the firing mechanism. The firing pin and cocking lever are inserted into the receiver and held in place with a locator pin. Then the safety, the trigger, and the trigger guard are installed, and the receiver is complete. World War II saw the advent of a rifle grenade that worked like a mortar and could travel 140 meters. A rod attached to the bottom of the grenade loaded into a standard rifle barrel. This crude launcher damaged the rifle and compromised its utility. Today, the modern grenade launcher doesn't damage the barrel since it's slung underneath, turning the gun into a double-duty weapon. With the hand grenade, once you remove the firing pin, you had 4 seconds to throw and run. The modern grenade launcher arms and detonates its payload differently. When the grenade is launched, the centrifugal force of the spinning missile arms the fuse. When the grenade hits the target, the firing pin is pushed back into the percussion cap, sparking an ignition, so that the grenade explodes on contact. The hand grip is a molded plastic sleeve that slides over the barrel for easy loading and protects the operator from burns. The grip is made by injection molding. Plastic granules are suctioned into the hopper, piped into the molding machine, and injected into the mold. The combination of heat and friction liquefy the plastic. Once the plastic is set, the mold opens and expels the hand grip. By the 1950s, the U.S. military had developed the M79, a purpose-built grenade launcher that looked like a shotgun with a huge barrel. These were used in Vietnam, but once the soldier was out of grenades, all he had left to defend himself was his small sidearm. So the U.S. military developed the M203 to fit on the M16 rifle. The launcher barrel is constructed of the same specially treated aluminum and is attached to the receiver. When the launcher is assembled, it gets a full function check to ensure the barrel latch and stop are doing their jobs. Finally, the receiver assembly is attached to the rifle barrel, and the M203 grenade launcher is ready to deploy. With the M203, the soldier can switch between weapons in seconds and engage targets that can't be reached by direct fire, converting a rifle from a weapon into an arsenal. Coming up on Battle Factory, the only airplane you can crash and reboot. It takes 12 months and millions of parts to create this structure that stands 9 meters high. But once inside it, you'll believe you're 9 kilometers in the air. Inside the cockpit of the CAE flight simulator, every nerve ending tells you you're flying, from the feel of the controls to the view out the window and the thrust of the G-force. In the military, by the time a pilot climbs into the cockpit of a real airplane, he's already had many hours of operational flying time without ever leaving the ground. It wasn't always this way. Prior to the advent of the flight simulator, learning to be a fighter pilot was actually more dangerous than flying combat missions. In World War I, 2 cadets were killed during training for every flyer killed in battle. Every simulator costs millions of dollars to make, but it's worth every penny. The CAE flight simulator breaks down into the motion control, the platform, the outer shell, and the flight controls. The flight control unit makes up the bottom part of the cockpit and houses the gears that control the flying movements the flight simulator makes, like thrust, pitching, and banking. The flight control unit and its many gears are milled from aluminum. The pieces are all modular and fit together like a complicated puzzle. The gears will eventually be connected to the hand levers on the control panel, the side stick, and overhead panel. They have resistance built into them to simulate the authentic feel of pilot experiences when driving the gears and controlling the aircraft. And every simulator is custom built to replicate a specific model of airplane, from civilian passenger jets to military fighter planes. The first simulator was developed by Edwin Link in the 1920s. He was an amateur flyer with a first-hand knowledge of engineering, electronics, and pneumatics from his family's pipe organ factory. He offered his Link trainer to the U.S. government in 1929, but they dismissed the concept entirely. The avionics panel contains the buttons, displays, and instrument panels that control the engines and navigation systems. Because every model of aircraft looks and flies differently, every simulator's avionics panel is a customized copy of the airplane it's meant to replicate. 3D printers generate buttons, knobs, and handles that ensure that the simulator's interface will look, feel, and function exactly like the model of plane that the trainee pilot will fly in the real world. Over 30 kilometers of cable are cut, identified, and thread into the panel. It takes hundreds of hours to do the intricate wiring. One error would cause the aviation panel to short circuit. Next, the brains of the cockpit, the circuit boards, are assembled. A programmed robotic machine grabs the tiny circuits and drops them in the slots on the circuit boards. Then, they're passed through an oven, and the circuits are fused onto the panel. There are hundreds of printed circuit boards in every simulator, performing thousands of operations per second. Today, flight simulators are a first option for training commercial and military aviators, but they got their start on the heels of a tough and tragic lesson. In 1934, Franklin D. Roosevelt recruited the U.S. Air Force to deliver airmail across America. Flying an aircraft that had been used in World War I, the pilots were given a civilian mission very different from their wartime experience. Pilots had to contend with stormy weather and unfamiliar airstrips. In the first disastrous month of the program alone, there were 66 crashes. The nation responded to this tragedy with an outcry. Roosevelt realized something had to be done. Coming up on Battle Factory, President Roosevelt turns to an unlikely source for help. In 1934, in the first few months of delivering the mail by air, the newly commissioned U.S. Air Force pilots were crashing all over the country. In desperation, Roosevelt and the Air Force reached out to the same person that had been rejected years before, Edwin Link. 6 Link trainers were ordered immediately. By the time World War II broke, there were 10,000 flight simulators in service. The cockpit module sits on top of the flight control unit and gives the interior of the simulator the look and feel of the inside of an aircraft. Built-in speakers broadcast everything from the roar of takeoff to the thunk of landing gear being deployed. Once the module is completely outfitted, it's raised onto the carriage and secured. The rest of the interior components are installed. The panels and doors of the platform are made from heavy-duty aluminum to handle the stress of the 10,000-kilogram simulator bouncing around for the next 20 years. The sheets of metal are cut and sent to a punch press that cuts the aluminum into various shapes and then bent. Then the components are assembled, painted airplane white, and baked to a hard finish. Once finished, the platform is attached to the flight control unit and the cockpit module. The simulator is capable of its unique movement because of the design of the bearings, which act like joints. They work together to choreograph an aircraft's 3 planes of motion: pitch, front to back motion, yaw, sliding on the vertical axis, and roll, tipping from side to side. Each of the bearing houses are made from aluminum and injected with grease to keep them lubricated. Each bearing will hold a leg known as a jack at either end, which allows the flight simulator to rock and roll. The visual bowl of the simulator, which is made out of fiberglass and aluminum, stands in for the cockpit window. The ever-changing visuals are projected onto a curved mylar screen, giving the pilot in training 180 degrees of virtual landscape. In the late 1950s, simulators would use film projection of scale model terrains, and then in the 60s, advanced to TV screens outside the cockpit. By the early 70s, computers were generating crude digital skyscapes. Today, the difference between a simulated and real cockpit is virtually indistinguishable, and the sophisticated flight programs can throw any dangerous scenario at the trainee. Extreme weather, equipment failure, emergency landings, and combat scenarios. 80 years after the first mail delivery disaster, pilots are required to do hours of simulator training. So by the time they climb into the real cockpit, they won't be winging it. Because once you've flown a simulator, you're ready to take off in the real thing.